explaining the siphon effect. The hero of Alexandria, the siphon effect. These words and concepts may be unfamiliar to you, but without them, our world wouldn't be the same. Before I explain why, let's talk about toilets. No, what do toilets have to do with siphon effect, may be wondering. Well, without the siphon effect, our toilets wouldn't be able to flush. When we flush our toilets, water overwhelms the opening at the bottom of the toilets and pushes water over the S-bend pipe of the toilet. This creates a vacuum-like suction which pulls the rest of the water and waste out of the toilet bowl quickly, due to gravity. But what is the siphon effect? Discovered in 240 BC by the hero of Alexandria, it is when liquid enters from a higher to lower pace on its own. The two leading theories are gravity pulling down, resulting in reduced atmospheric pressure, and the cohesion tension theory. Before we go any further, let's do a quick science experiment. Hi, today I'll be showing the demonstration for our siphoning effect. So first, you want one cup. This cup is empty, you can see, nothing inside. And you want one cup full of water, like to the brim. And you want a straw, like about, you can cut it if it's too long, but it should be about the length, the lip should be right, the bend should be right at the lip of the cup. So first, all you want to do is to hold your finger over the shorter end of this cup. Shorter end of the straw, just hold it right there. Yeah. Then, you want to submerge the whole straw inside the cup. Okay. Now, next part is going to be tricky, so you want to quickly move over. Okay. It might not work the first few times, so I'm going to try again. I'll show. Okay. Now, I'm not sure you can see this, but the siphoning effect is currently happening. So if you take a look, water is being drained out from the straw from one cup to another cup. Okay, now next we'll show the demonstration, the explanation of the demonstration in the next slide.
The siphon effect works. Here's what it looks like before the siphon starts. Both ends of the pipe must be in the containers or else the water will flow out. Now, the flow begins. Gravity pulls water down one side and the atmospheric pressure pushes the water up from the other side because of the pressure difference, which allows the water to flow. Eventually, the water finishes transferring to the lower container, and as long as the end is lower than the start, the siphon effect keeps going until the source runs dry, or until the pipe cannot reach more water. However, if the height is not lower, like if the lower container is not lower than the water level of the higher container, the water will stop flowing until the water level reaches the same.
Next, we have the cohesion tension theory. Water molecules are very cohesive due to hydrogen bonding. As such, they tend to stick together when placed together. So when water reaches the bend of the tube, gravity starts to pull down the water molecules at the front. Then water molecules behind the falling water are pulled along, similar to the chain fountain phenomenon with Newton's beads. This explanation doesn't involve atmospheric pressure and explains why siphons work in a vacuum. Why does this matter? The siphon effect is incredibly useful in real life, in toilets to flush waste, in farming for irrigation, in science labs to prevent spills, even for fuel transfer in cars or planes. So, the next time you flush a toilet or water flows mysteriously uphill before going down, remember, it's not magic. It's the siphon effect, a 2000-year-old trick still flowing strong today. Thank you.